Okay, let's go to page 71, and this is section 6.2. This is multiplying and dividing polynomials. So when you multiplying polynomial, you just go and use the distribution, use the, just distribute it out. So when you have like x squared plus 3x plus 1 times x squared minus 3x plus 4, you just go and distribute, just multiply out, okay, from your algebra 1. And after that, you combine the like terms. Or you can use the vertical method like this one over here, and you just go and multiply and you just go and work it out, okay. Now over here it says a degree. When you multiply, so degree of the function of x and times function of g, function f and function g. When you multiply two functions together, their degree would be, you're just adding the degree, okay. And the degree is the highest term. So like this is a degree 2, and this is a degree 2. So when you multiply this together, you're going to get degree 4, okay. And when you're doing a division, like this one over here, when you're doing a division, you can just go and use the long division. In this case, you'll use long division and divide it out, okay. Now when you go to page 72, this has to do with the quotient and remainder. So when you have f of x divided by g of x, this will give you q of x. Q is a quotient. So again, when you have, again, this is like this one over here. So when you have a polynomial divided by a second polynomial, you're going to get a quotient plus the remainder. So this is r of x over g of x, okay. So again, when you have a function divided by another function, you're going to get a quotient plus the remainder over the divisor. Divisor will be like your denominator, okay. So this is one form of writing it. Another form to write this is when you multiply. So you're going to get f of x will equal to the divisor times the quotient plus the remainder, okay. And also remember that the remainder will always 1 degree less than, at least 1 degree less than the divisor. So if a divisor is a second degree, then this can only be 1 first degree, and so forth. Okay. So this is a very important equation to know, and we're going to use a lot of this later on. Okay, now what we're going to do next is that when you're doing the long division, sometimes if g of x, if the divisor is like a polynomial, like second degree, then most likely you have to use the long division like this, okay. But if the divisor is linear, then you can use synthetic division. So for example, if you were to divide x squared plus 3x plus 2, if you were to divide by x minus 1, okay, so normally you would just use the long division. You got x squared plus 3x plus 2, and you just divide, okay. But another quick way of doing this is using the synthetic division. So synthetic division is you just go and use a coefficient. So this is 1, 3, 2. Now if there's a missing term, you have to put a 0 for that spot. And when you divide, you have to take the opposite, okay. Just as if you were to solve for x, the x will equal to 1, right? So you have to put 1 over here. So you drop the first term, then you go and multiply, and put over here, you add, multiply, then you add, okay. And the last number would be your remainder, okay. Let me see. Let me double check. Okay, so I multiply, you add. Oh wait, yeah. Okay, so this is x squared. I copied the problem wrong. Okay, so let's say if you're doing this division, okay, so your answer would be becomes x plus 4, and this your remainder would be plus 6 over x minus 1. Okay, so if you were to use this, divide by this. Okay, let's go to. So if you look at page 74, okay, it says there are a couple things. There are a few things you need to know about synthetic division. First, it only works when we are dividing by a linear polynomial. Okay, you only can divide when there's no number in front. Secondly, the leading coefficient of linear term must be 1. Okay. Again, you only can divide by a linear, and also this must be 1. Okay, and also when you divide, you have to use the negative of the constant term. So like I put over here, so this has to be opposite the negative of that constant term. Okay, so if it's a minus 1, you have to use 1. Okay. Okay. So let's go and go over some examples, more examples. Let's go to example 6-1. So you're going to use a synthetic division to divide 8x to the 4 minus 12x to the 3 plus 2x plus 1 divided by 2x plus 1. Okay, so now you cannot use a synthetic division right away because there's a 2 in front. So in this case, what you can do is divide everything by 2. Okay. Now, if there's an odd number, it kind of makes things a little bit messy. Okay. So you can go and divide by 2 on everything first. So you're going to get 4x to the 4 minus 6x to the 3 plus x plus 1/2 divided by x plus 1/2. Okay. So you can just divide it by 2 to get rid of that 2. So double check, make sure it's half, 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 half. Okay, everything divided by 2. Now you can use synthetic division. So you're going to get 4, negative 6. Now notice there's no x squared, so you have to put 0 for the x squared term, 1, 1/2. Okay, divide, and you have to take the opposite. You have to use the opposite of that. Okay, the way to think of it is if you just solve for x, you set this equal to 0, solve for x, so it'll be negative 1/2. Okay, so you drop the first term. Okay, you multiply. You add, multiply, you add, multiply, you add, multiply, and you add. Okay, so this is your remainder. The last number is your remainder. Okay, and let me double check. Positive. So this would be a 1. Okay, there you go. Yeah, so be careful. It's very easy to make mistakes. Okay. Okay, so, and how do you know what does this mean? Well, notice x to the 4 divided by x will give you x to the 3. So that means this is the x to the 3 power. So this will be 4x to the 3 minus 8x to the 2 plus 4x minus 1. And the remainder will be plus 1 over the x minus 1/2. Okay? And if you want to recover this, right, since this is a complex fraction, so you can multiply by 2, right? So you're going to get 4x to the 3 minus 8x squared plus 4x minus 1 plus 2 over 2x minus 1. So that's how you recover your divisor, okay? And that would be your answer. Okay. And again, this kind of fulfill this, right? Again, when you divide, you're going to get, here's your q of x, right? So it's going to be q of x plus r of x divided by over the remainder over the divisor, right? So remainder over divisor. So this is this right over here, okay? Again, if you cross multiply, the original function would be this. So you're going to use this a lot to kind of get the original function or get the q of x, okay?